In this video, we are going to practice factoring trig expressions. The main hint here is that it works just like factoring quadratic equations. So if you can factor a quadratic, you should be able to factor a trig expression that we're going to practice here. Example 1. Factor secant squared theta minus 1. Some of you are thinking, are we simplifying or are we factoring? Because if we were simplifying, secant squared theta minus 1 actually is part of one of the Pythagorean identities. You should refer to the other videos or your notes to figure out which one, and it might be a good practice to figure out which one. But right now, we're practicing factoring. So this one looks to me, it's similar to something like x squared minus 1, which you should know how to factor without even thinking about it. X plus 1, x minus 1. So this becomes secant theta plus 1, secant theta minus 1. That's it. That's all we do when we're asked to factor. Let's try another one. Let's factor this time 4 tan squared theta plus tan theta minus 3. So this one is similar to 4x squared plus x minus 3. You should be able to factor using 4x, x, let's put minus 3 over here, plus 1. Looks good. So we factor and we follow similar kind of methods, and we get 4 tan theta minus 3, tan theta plus 1, and that's all we have for factoring. Let's try one more example. Factor cosecant squared x minus cotan x minus 3. So this is a little wonky because we actually have two different expressions here. We have a cosecant and a cotan. So a hint here is to use an identity first. Again, remember, we can only use the identity in this expression because this is the one with the squared. All the Pythagorean identities have squareds in them, and so we must replace cosecant squared. Take a second, flip through your notes. Hopefully you can figure out that cosecant squared is equal to cotangent squared plus 1. So cosecant squared x becomes cotangent squared x plus 1, and we keep everything else the same. Collect like terms, plus 1, negative 3. We get cotan squared x minus cotan x minus 2. You should all be able to factor this to get cotan x minus 2, cotan x plus 1, and that's pretty much it for factoring. So some of you are wondering, why might we factor? Well, let's take a look at another problem, for example. The reason we usually factor is to help us solve an equation. So another problem might have you solve, say, cosine squared x minus 1 equals 0. Of course, there are going to be many different ways to solve this, but one of them would be to factor. Cosine x plus 1, cosine x minus 1 equals 0. Well, now we said this portion equal to 0. We said this portion equal to 0. So cosine x plus 1 equals 0, so equals negative 1. Cosine x equals 1. Hopefully you all remember from your unit circle when this is true. This is going to be true, let's say let's only consider 0 to 2 pi, or 0 to 360 degrees. In that case, cosine x is equal to -1 where? Where does the x value equal -1? Do some flipping through for your unit circle. And you'll remember that x cosine equals -1 at x equals pi. When does cosine equal 1? X equals 0. And so, again, factoring is going to be a necessary step in order to solve equations. We're going to talk more solving next video. This video is mainly to practice your factoring using substitutions, and I just wanted to show you when and why we might use them in the future.